Okay, so this is where we were at. That we started to build this basic calculator, and I left things pretty much to you guys. Do this at home. Did you guys manage to do it? The other operations shouldn't be too difficult. There was another somewhat interesting homework, and I wanted you to write a method that converts a string to an integer. Did you guys manage to do that? Okay. Anyone else? No? Well, since that involves a bit of thinking, some sort of algorithm, let me just give you the idea, so that if you're asked to write methods like that, you should be able to do it. So let me write down the task again. We want to write a method that does something like this: public int convert to integer, and we give you a text. So you're supposed to write the body of this method, something as such. Okay, and what would be your input? Input, let's say, is 1276, and then the output will be an integer that's 1276. The problem that I asked you to solve is the same as converting from binary to decimal, for example. You have done that quite a few times, even if you haven't written a program. Let's say I give you input binary string. If I give you 11010 this and ask you to convert to decimal integer, you should be able to do that, right? What is this, by the way? How much is this? What is the number that I have written over here? In terms of decimal, not in binary. Do we really need a calculator for this? 26. Yeah. 26. And this is important to understand how to do it without a calculator to actually solve this thing fast enough. You see, converting this into decimal, we learned to solve this problem in the wrong way. Well, that's actually not, that's technically correct. I mean, what you'd probably do, for most of you, is when you're given this task, you will write this as, this is 0 times 2 to the power 0, and this is 1 times 2 to the power 1. Here we got 0 times 2 to the power 2. This is 2 to the power 3. And this is 2 to the power 4. Okay? So it will give you the correct answer. Yes, it will also give you 26. But I mean, it's actually unnecessarily complicated that you have to calculate the powers of 2 like this. Whereas what I'm going to suggest right now should be quite easy to follow. And you can do these things by yourself without the help of any calculator. How many of you have done DLD already? Digital Logic Design? Just 2. Alright, then some of you are doing this in this semester. Okay, even if you haven't done DLD or forgot everything, I mean, that's just fine. Let us start with the very basics. We got 2 bits, 0 and 1, right? And they also correspond to decimal values. So 0 in binary is 0, 0 in decimal is 0. 1 is the same. But after that, things start changing. If you write 1 0, that is not 10 in decimal anymore. This is actually 2. So 0 1 2, it goes like that. Now, what I want you to understand is what happens when you write 3. So that's 3, right? So every time, you see, if you start with 0 and 1, if you add a 0 right at the end, it means that you multiply the previous number by 2. So 0 after a 0 means it's still 0 because you had 0 to start with. You had 1, right? If you put a 0 after this one, it means that it will multiply the previous value by 2. So 1 becomes 2. Let me give you some other example. I mean, these numbers will come down further down the line. So let's say we have 1 1 0. This is 6. Okay, 1 1 0 is 6. Why? Because 1 1 is 3, and you're putting a 0 right at the end. It means that the number that you'll get is going to be 2 times this thing. Okay. This is not really rocket science, and you have seen these things before. Where, let's say, I have a number 25, okay, in decimal number system, not in binary, because 25 is not like that in binary. So if you have 25 in decimal and you put a 0 after that, that really means that the number is going to be 25 times 10. Why multiply by 10? Because we got base 10. Every time you add a 0 to the right side of a number, that means that the previous number is actually multiplied by 10. In decimal, it's just the same thing. If you put a 0 right at the end, it means that you multiply the entire number by 2 because the base is 2. Okay. So let us look at another scenario. Let's say I have 256. What is this actually? This is 25 times 10 plus 6. So the new digit, if you add a non-zero digit, that really means you have to multiply by 10 regardless, and then you add that non-zero digit right at the end. So whatever you're adding, it's actually multiply by 10 and add that digit. If you add 0, that means that you're doing nothing, and it's the same concept. So if you take the same knowledge back to binary, see we got 1 and we put a 0 right at the end, it means that it becomes 6. What if we have 1 1 1? See, the problem is now easy to solve because we know what 1 1 is. What's 1 1? That's 3. And after that we are adding another 1. That means that you have to multiply by 2, then add 1. So 2 times 3, that's 6, plus 1, this is going to be 7. And all around we are going to follow the same thing. So this is going to be 7. Let me write this down. And over here you had 1 0. This is 2 already. If you had a 0 at the end, it means that it would be 2 times 2, which is going to be 4. If you had 1 0 1, 1 0 is 2. 2 times 2 is 4. Add 1 to that, this is going to be 5. And then you have 6 and 7, right? Is this thing clear? Okay, so why did I say that you don't really need any calculator to convert this thing into decimal? Let us try this out in the same process. We're going to start from the left side. We're not going to start from the right side as you have been taught to do. Let us just start here. What's the first number that we start with? This is going to be 0. Initially we start with 0. Okay. We get 1. So this 1 is added after this 0. So what does that produce? 0 times 2 plus 1 equal to 1. Okay, so we have processed till this part. This is done. I hate this. Now I can't do anything else. it's not responding to clicks. Just a bit, some weird issue with this journal. Okay, so we got from 0, 1, we got 1, all right? Now, what would be the next digit you find over here? 1. So that means you have 1 and you added another 1 right at the end. So this 1 becomes 3. 1 times 2 plus 1, it becomes 3. Then the next number you got is 0. So that means you double this thing. This becomes 6. Okay? And after that you have a 1. That means this is 6 times 2 plus 1, that's 13. And finally, when you have another 0, this is 26. So if I give you a slightly longer binary string, so for example, if I give you this string to process, can you tell me what's going to be the decimal equivalent without using a calculator? I've probably taken it a bit too far, but it's not being too much. Maybe. So let us check quickly. So I'll speed up things a bit. This is something we already know probably. 1101 we have seen that before, and this is 13. Okay, this is 13, and a 1 after that. That means how much? 27. This is 27. This is 54. 54 times 2 is 108. This is 109. 109. This is going to be 218. 218 times 2, 436 plus 1, 437. So yes, that's what it is. So yeah, I mean, just by going from left to right in a single scan, you can convert this entire binary string into a decimal number. And how is this thing related to this 1276? Because if you understand this process, this is nothing different. Start with 0. What do you get? 1. So 0 times 10 plus 1, that's 1. Then we got 2. So that's going to be 1 times 10 plus 2, that's 12. Then we process 7. This is going to be how much? We had 12 before. 12 times 10, that's 120 plus 7, that's 127. And then we have 127 times 10, that's 1270 plus 6. This is 1276. This is how we convert this. This is the general idea. Now once you have the idea in your head, it's not too difficult to translate this thing into any programming language for that matter. You just have to know a few functions or methods, whatever they're called, and then act accordingly. See, in Java, I'm going to write this down just to make sure that you follow the process. I mean, if you have some sort of an idea to solve a problem, at some point in life, you should be able to write a program to do that. I'll just start a new project. I'll just make it a Java application. And let me put it in our Spring 2018 Java folder. So this is going to be text to integer. That's the project that we're going to write. And over here I want to call a method. Let's declare a string. Let's say string text equal to 1276. That's the text thing, and I want to convert it into a number. So I'm going to call this text to, what did I call it? Let me check. Convert to integer. Thank you. Convert to integer, and let us pass this text. It will magically convert this to that number. Then we can print this out, or we can check, like we can do operations like number plus plus, because it's not going to be allowed on text, and we can then print it out, this number, to see whether we got it right. Okay, and we're going to create this method over here. We will write this thing. So let us go to the end. We'll delete this. So in this convert to integer method, one thing you need to understand is how you're going to write this thing. If you follow the process, we go from left to right and do it for all the characters that are there in this string. So we're doing the same thing over and over again, but we do go from the first point to the very end. So you need to know how you can write a loop for that. We're going to write a loop, obviously, because we don't want to do things manually over here. So first of all, the number you're going to return, let's say we initialize that to 0, and finally that's the number we will send back. So that's the first statement, and this is the last statement of the method. That's what it is. Then we need to write a for loop that starts from 0 and goes through all the characters of that text string. So text dot length, there is a method called length, and for this you need to really study the Java documentation, go through your textbook to know what are the different methods that are available for string class. I already asked you to look at it. I gave you some homework that look at the starts with method or look at the character at method. Those for a different purpose, but you need to know that. So we go for the entire length of it, and then we go I++. So what we get with this index I is a character. So if you do text dot character at I, let us see what we get. Let's say we declare a variable called ch, okay, and we're just going to print that out. I'm going to go a little bit slow over here, but I just want to make sure that you guys understand what's happening. Okay, so this is simply going to return 0, but what you see is that these are the characters that we found. We found 1, we found 2, we found 7 and 6. Is this thing clear? Okay. So the next thing we need is we need to get the digit out of it. This is a character, but we need the digit. So let us convert that to digit. Okay, and we can do a typecasting like this. And let us print this out to see what we get. See, for 1 we got 49, for 2 we got 50, for 7 we got 55, for 6 we got 54. Why is it like that? Yeah, these are the ASCII values for the corresponding characters. 0 is 48, and it goes up from there. Lowercase a is 97, uppercase a is 65. Okay. So I'm not asking you to memorize these things. You don't have to. But what you need to understand is that the ASCII values, they go in a sequence. So after 0 comes 1, then comes 2, then comes 3, 4, 5, 6. After A, we got A, B, C, and D for both the lowercase and the uppercase. So if you want to find out the index or the serial of this thing, you don't really need to go any further than just to delete this thing or to subtract the starting one. So whatever I have, if I have 3, if I subtract 0 from there, 3 will be how much? 48, and then 49, 40, 50, 51, 52. Then we're going to subtract 0 from there. 0 means 48, so you just subtract from there, and then you get the value. So if I do that, now this lines up. For 1 I get 1, for 2 I get 2, for 7 I get 7, and so on. Is this process clear? That we can go through each and every character of this text, and we can get the character out, and we can also get the digit out just by subtracting ASCII character 0, because they are all in serial. We get 0, 1, 2, 3, and so on. So now that we have the digit, the problem is much more simpler, because the process is whatever number you got. When you get this number, you multiply the previous number, add the digit. Multiply the previous number, add the digit. It's as simple as that. So instead of printing this out, like what I'm doing here, instead of printing this out, what we do is we just say number equal to whatever the number was before, multiply it by 10, and add digit to this. And after you're done, you just return the number, we add 1 to it, and then we print. So the number, the output, if these things are done properly, the output is going to be 1277. Is this thing clear? Let me know if you don't understand any part of it, because I'm going to give some homework based on this thing. All good? The second task is a bit of a challenge. The first one is not so much. What I'm saying over here is that this thing works only for positive numbers. So if I give you a number like -1276, you're not going to get the right output. Okay, that's totally off, right? So you need to fix that. That's the first homework. So if you got a negative number that starts with a negative sign, you need to proceed slightly differently. It's not so much of a big deal. You just have to write some if-else. Okay, and adjust accordingly, like you have to start at index 1. I pretty much give you the answer right there. So make sure that it works for that, or people may, for no good reason, add a plus over here to say that this is a positive number. So depending on the sign or the lack of it, your program should work regardless. Okay? So see if you can write if-else statements to make sure that it works. The second one is more of a challenge, that you may have numbers like this, floating point numbers, and you need to convert that to double or to fourth. How do we do that? Well, if you go here, you're actually multiplying by 10, but if you go to the right after the dot, you're actually dividing by 10. The further you go away, it's actually dividing by 10. So try to figure that out, what happens over there on the right side of the dot. I'm not going to explain this here. That's why it's left as a homework. Try to do it on pen and paper, see if you can get the idea right. If you can't, then try to translate that into the program. I mean, the base part is given over here. It would probably be easier to do it separately, like do this part separately and this part separately in the same method, but in 2 different parts, and then add the corresponding parts together, rather than going in a single form. Try to do it in 2 parts. And if you want to know where this dot is, that's easy to find. If you use index of, there's an index of method in the string class. If you use that, that will tell you the index where you can find this thing, a particular character, if that character is there. Otherwise, you'll get probably -1 or something as such. Okay. So I'm going to leave this as homework. Let me know in next class or through Google Classroom if you manage to solve it or if you run into any trouble. Okay, so that's one of the things. I mean, this is related to what I gave as homework in our last class. It's written over here. That's why I wanted to talk about that. Oh, and also, just as a reference, for evaluating polynomials. Okay, so this is important not for this course, but for many other things. The process that we follow, going from left to right, can also be used for polynomial evaluation. Do we know what polynomials are? It's a function, really. Polynomials are functions. And you have seen that, just maybe not in this name. So let's say I have 2x squared minus 5x plus 20. Have you seen equations like this? I mean, so this is what a polynomial is. In polynomial, it's a simpler function that all you have will be powers of x. Okay, so there will only be powers of x multiplied by some constant values. These are the coefficients over here. Okay, so this is a polynomial. And evaluating a polynomial means instead of x, let's say I'm going to put some value. Let's say I'm going to put 5. What would be the value on the right hand side? We can find that out by calculating 5 squared, also multiplying 5 with 5 and then putting everything together, we can find the value. But that's going to take time because there will be repetitions, there will be, let's say, x to the power 10 or x to the power 6, we have to multiply it that many times. Horner's rule is actually what we have followed over here without mentioning the name. So if you got time, when you go back home, look at this thing on Google or look at this Horner's rule in your math book. It's actually a way of evaluating polynomials, and that's very closely related to what we just talked about, because this is also nothing but a polynomial. All you see over here is powers of x, and the coefficients, they're either 0 or 1. In case of decimal number system, this is for binary. In case of decimal number system, the coefficients can be any number from 0 to 9. But for x, what you'd have is x equal to 10. So you evaluate that at that point. So yeah, just look at this. This is not for Java course, but you're going to find it very useful for many other purposes. Particularly if you're into programming contests, then yeah, definitely these things will help, or at least the knowledge of that. Okay, so what I want to go to, I mean, we were talking about this basic calculator thing, and we are pretty much done with it. There is a ton of things you can add to that. When I go through this course, I will come back to this calculator from time to time and give you some hints that what different things we could add based on the knowledge that we gather. What we know for now, I think this would do, and it's up to you to add the basic stuff. Okay. What I'd like to move on to is file input output, because we need that knowledge to work on our assignment. I gave you a brief idea about the assignment itself. It's going to be a banking system where we can do our transaction. We can withdraw, we can deposit, we can open accounts. It can be many different accounts. We will be able to see our bank statement, like our transaction history, on which day did we withdraw some money or we deposited something, what's our total balance. We can find all these things out. But to do this thing, one key thing we need is to save our previous history. Okay. Just to give you a very simple example, let us say that we develop a system for Southeast University by which we can store the records of all our students. Yeah, we can store that in database. Okay? But database is a slightly more advanced topic. We will talk about that after the midterm. But for now, what we need is, in some way, we need to store the records. Otherwise, every time you start up your application, everything will be gone, and you have to enter them again. So let's say I want to give grades to you at the end of the semester. If I had to type in your name every single time, that would be a bad system. Okay. Like the attendance sheet itself. I mean, if I gave you a blank sheet, which I did right at the beginning of the semester, and you had to write your name every day that you had to sign, that's a bit of extra work. Whereas if I can pull this from a existing source, like our database, then that's readily available. Okay. So there should be some sort of program that would help us write these things. So I'm going to create a new project to give you a brief demo of how we can store things in a file. Because every time you're going to start an application, we can read from there, or we can also use that to write to files. I will do a console application here without using a UI to start with, but I will show you how you can hook it up with a UI and then process from there. Okay, so file IO is the name of the project. IO stands for input and output. Okay, and I'll do two examples over here. Read from file. I'll call a method read from file that reads from file and prints the output to the console. Okay, so we got this method. Oh, by the way, let me just show you. Since we're using an ID, from time to time I take advantage of that. What I could do is I could write this method by myself, public static void read from file. I could write this by myself, okay? But in NetBeans and also in other IDs, if you call a method that doesn't exist, it gives you the option to create that. At least it writes the first line for you. Okay. So I'm just lazy like that, so and I can say alter enter. If you press alter enter or click on that balloon, it gives you an option to write that. And it starts with throw new unsupported operation exception, that if you try to run this project now, it will crash because you called a method for which you don't have a body. So NetBeans just puts that in place to make sure that you know that this is something we need to write. Okay. Alright, so we're going to read from a file, and let me just show you what we do here. No, not my desktop. So in our NetBeans projects, we have Spring 2018 Java. We have this file IO project. Okay, it's going to be easy if I put a text file over here and start reading from there. It doesn't mean that we have to place our file that we are going to read from over here. It can be in any other location, but for convenience, I'm going to put it over here. It makes my life a lot easier. If you put it in the root directory. So this is Spring 2018 Java, and then this is the root directory of the project. This is the project that I created. So if you put a file here, that's going to be really easy to read. So let us just create that file. New document. It's going to be an empty document. Okay, initially, and I'll just call it input.txt. Not like that though, like this. So we have a file called input.txt. And in this file, I'm going to write some random lines. Okay, like quick brown fox jumps over the lazy dog. So what's so great about this? Yeah, this sentence has all the characters from A to Z. uses all the letters from the alphabet. All right. Okay, so we got 3 lines over here, and it can be any other lines. They don't really have any significance, really. I'm going to write a program that reads from this file, and whatever it reads, it will print it out on the console. Okay. So previously, we talked about the scanner, right? In probably the second class, we talked about scanner, and just to rehash, this is what we did. We created a scanner, an object of scanner, and we had to tell that scanner where it's going to read from. Okay, and we could say scanner dot next line, perhaps, right? So if you want to read a line, you could say something like this: string line equal to scanner dot next line, and then print that out. Okay, this is not reading from file, but I just want to set up the context. So you can read from the console and then print it out. Okay. The idea, what we are going to implement over here, is that instead of reading from a file, from the console, if we somehow try to read from a file, and the file is input.txt. Okay, does it work? No, it doesn't work. But we are going to use something similar. So over here in scanner, what you can do is you can give a string and it's going to read from there, or you can actually give the console itself and you can read from there. But scanners, we don't really use that to read from files. Okay? We use something else, but it's going to be based on similar sort of idea. So the tool that we're going to use here is not called scanner, so we're going to change that name. This is called random access file. Okay, and let us say that the object that we create is called input. So we have to create this object. We say random access file, and it's going to read from that file. But with random access file, you can read from the file and you can also write to the file. So you have to say what you really want to do. Over here we are saying R to signify that we only want to read. We are opening this file in read-only mode. We're not going to write into it. And then we write input.nextLine, just like this. Okay. It's complaining right now because it doesn't know about random access file. It's in a separate project, package rather. So we have to say java.io.randomaccessfile. See, if I write that, now it doesn't complain anymore. So I'd have to write java.io.randomaccessfile over here again. What if I don't want to do that? We import. Okay. So we go up here and we say import java.io.randomaccessfile. So once you say you have imported this, now that's better. It's not complaining about not knowing the class name. It's complaining about something else. Okay. So first of all, I'll do things without explaining. Let me just fix this error by writing something cryptic. The method to call is actually readline. So just to show you that this actually works, please ignore the throws exception for now. We will get rid of that. See, we can read a single line. Okay, and if you repeated these two things, not, I can't declare the same variable, the same object multiple times. I cannot declare that with the type name. So I'm fixing those. Every time I'm reading from the input file and printing it out, I did it 3 times, and I can read the entire file. Is this process clear? Okay. So I'll explain what I did over here, and we're going to do it in a different way also. See, Java, in programming Java is really very easy, because you as a programmer, you will be prompted to take decisions about possible mistakes. Okay, so we're back to the problem again. I removed the 2 words throws exception for both these methods. Now we have compiler again. See what happens over here. You're trying to read from a file, read the content and print it out. That's the purpose. What if the file is not there? Okay. I have left the file input.txt in this folder, but this is not in control of this program. The operating system controls this. You have all the access, and you can now delete this file from here. So if I try to read that now, what would happen? Will I be able to read it? No. Let me give you an example that's more common to you, I guess. Let's say we install antivirus software on our Windows PC. And when you're going to run that, it's going to ask for internet connection, because it's going to download the virus database from the internet to know about the latest threats. What if you don't have the internet connection? Can you do anything with that? Well, you can, with the given database that it has, and then it will soon complain that it's outdated and you need to download things again. So that's the problem, that if you imagine that you want to chat with your friends through Facebook Messenger, but if you don't have any internet connection, you have nothing to do. Right? So the program, the Facebook Messenger program, it has to check for the internet connection first before sending out your message. Okay. If you're trying to, let's say, copy a movie to a pen drive, that pen drive needs to be there physically attached to your computer. And what if someone comes to your room and randomly pulls out the pen drive? Will your computer still be able to copy this? No. There will be a problem, right? So Java programs let you guard against those sort of errors by taking care of all these exceptional scenarios. So the expected behavior right over here is that the file will exist. What if the file doesn't exist? Well, you can tell the user, give me a different file to read from. Or you can at least tell the user, the file that I need is not there, so please put the file back in and then run the program again. If you don't do any of that, if you just crash right there, the user doesn't get any feedback. Okay, and that's a very bad user experience. You have to inform the user what happened and what could be the possible remedy. That's why in Java, every time we try to do any of these things that may result in exceptional behavior, what we do is we catch them. So notice the words that I'm using. We try to do this. Okay? So we try to do the following things, but we should be ready to handle exceptional scenarios like file not found exception. That's the name of a class, and it's quite self-explanatory. You can understand what it means. What if the file is not there? What do you do there? So this is the name of a class, and to use this thing we have to create an object out of it, and usually we just do it in this way. Why FNFE? is the first letters of each of these words. File not found exception. Okay. And now it's also complaining because it doesn't know about the class. See, either you write it this way, or you import java.io.file not found exception. Now once you have this thing, what if the file is not here? Then you can complain by saying right, that we couldn't find input.txt. So let me just comment this part for now, because I only want to focus about the file not found exception. See, now the program compiles. It also works, it says nothing, right? But suddenly, if you, for some weird reason, if you change the file name, now input.txt doesn't exist. We have input1.txt, which is not the same thing. And if you try to run this project, it complains right there. So that's a nice feedback to the user of the system that yes, it needs that file, it couldn't find it. Now what to do? Well, you can just gracefully give the message and stop running the program. You can do that, or you can suggest some remedy that you can prompt the user to give you another file name, and then you can try to do the same thing again. Okay. So the control comes back to you as a programmer, and this is our try catch block. So to repeat the whole thing, that if you have any part of your program that may behave exceptionally, okay, you're going to expect that things will be all right, that you can read from a file, but there can be exceptional behavior that the file is not there. What to do? Well, you catch that and you do that here. You try to do something. If that fails, you put that here. Okay. So this is not if-else statement, by the way. Looks like if-else statement. If this condition is not met, you go here. It may look like that, but it's much better than if-else statement in this scenario because it has the mechanism of testing this thing, whether this fails, and then you act upon it accordingly. You don't have this feature in C, by the way. In C++, yes, we do have try catch. Okay, so let us go back to this other problem. That if you try to, where is my comment? I lost it somewhere. Oh yeah, couldn't see that. All right, so now we have a problem again, and let me take my cursor over here because we need to understand the error messages. It says unreported exception, IO exception must be caught or declared to be thrown. So previously we had file not found exception. Now we have something a little bit different. We have the file. Yes, we know we have the file, but still we may run into trouble reading from the file. And that's the example that I was giving, that let's say you have a pen drive, and I was talking about copying, that's like writing. Let's say we want to do it for reading. An example could be we downloaded some movie, took it on a pen drive, and we're trying to read from that. Our movie player, they're doing nothing but reading, and then displaying that onto the window, right? So in the process of reading this thing, if you take out the pen drive, your program may crash, or it may report to you that the resource is not there, it cannot read from it anymore. So the question is, was the file there when we started? Yes, it was there. Can we still read from it? No, we cannot. So what do? We have to tell the user or do something about it. Okay. It may also happen that it's not the case of you pulling out the pen drive. It may happen that you have some damaged file. Okay. It can be, if you're talking about hard disk, it can be bad sectors. If it's about a zip file, maybe the file was not downloaded properly, it's corrupted, so you cannot read from it. So the file physically it exists. So it's not a matter of final found exception, it's a matter of IO exception. You cannot do input out operation with that file anymore. Is the difference clear to you? It's a different story, that's why we need to be ready to capture that as well. And that's where you have to add IO exception, and this one I'd write IOE just like that, and let's say now it complains about IO exception. It's because we haven't imported java.io.io exception. So yes, just do that, and we are ready. So it's complaining about the input file because I purposefully changed that, and let us take it back to input.txt. Is this thing clear? That these are the exceptions that you need to handle when you read these things. All right, so let us try to do a little bit better. See, we are reading 3 lines by copy pasting the same code. This is not how we write programs. And if I try to read 4 lines, I'd do like this, or 5 lines, I'd go like that. Now, let us have a quick look at the output. What do we get? We get the first 3 lines all right, then we get null and null. That tells us something, that if you don't have any more lines, it's going to return to you null. A null as an object means that it doesn't exist. That thing is not there. Null is not the same as an empty string. An empty string means that the string is there, it's just that there is no character in there. But when you have a string as null, it means that simply the string itself doesn't exist. So armed with this knowledge that we know that we will get null when there is no more line, we can actually write a nice little while loop. Okay, while this is true, this is actually an infinite while loop that we're writing right now, but we will change that in a bit. So since we are repeating the whole thing, why not write it in this way? Okay, because these are the 2 lines that keep on repeating, right? You read a line, you print it out on the console. This is all that we're doing. Let us run this. And since this is a never-ending while loop, it keeps on running without any stop. Okay. Right at the beginning, we got the 3 lines, and after that, it's all the null lines. And if you understand this, it's easy to fix, because we'd be getting line equal null when there is no more line. We've seen break in our C course, right? If you write a loop, you can break out of it based on a certain condition. In Java, we have the same thing. And that's that. We can read a file. Is that clear? So this will be quite important, reading from a file if we're going to do the assignment, because we'll be writing all our data, all our transaction data into files, and then we need to process these lines and make some sense out of it. But that's a different story. For now, we at least need to know how to read this thing. Any question about any of these things? No? Okay. So we know how to read from file. Let us quickly have a look at how to write to a file. Okay, let me write another method. Write to file. Okay, so we have read from file, and we got write to file now. So we're going to create a method like that. Let me delete this line. The idea is that we'll have some string, and we want to write it to a file. And let me comment this out because we don't want to read from a file. We will call the second method now. Okay, so this is the message that I want to write. And let's say, just like we had input.txt, we will have output.txt as our output file. So the same drill again. We will have to create random access file output equal to new random access file. And this is where we write output.txt. And this is where we will have to write the write mode. It's just that it's not going to work with W, because every time you write something, you also need to read something. Like you need to read what's the length of the file. If you want to jump to some specific place, you need to tell that. So that's why we have R for read, and for writing, this is not W. This is actually RW. This is actually read write. You have to do both. So we got the output file like this, and now to write something, I will write the try catch later on. To write something, we should say something like output dot write bytes, and then put that text in. That's it. Okay. So to get it to work, what do we need? We need the try catches, just like before. So let me just steal my own code. We got the try, and I'll also copy the catches. Okay, and let us format things a little bit better. Alter Shift F, that will fix the formatting for us. And if things go right, we will have this message written to a file called output.txt. Okay, so a very quick test. It says nothing because there is no output to write on the console. But if you go back to this directory, we see that there is a new file called output.txt. Let us open this up, and yes, that's the message we got. Is this clear? Okay, so let us try something a little bit different. Let's say, instead of saying this is the message, we say hello, just like this. And we run the program again. So it asks us to reload because the file changed. Is this what we expected? Maybe. See, what happens when you write to a file, it doesn't really erase off everything. Every time it starts writing, it starts from the very beginning of the file. So it started right here, but it didn't erase everything. It just overwritten these 5 letters and nothing else. So the other parts, they're removed. Now there are 2 things you may want to do. One is you erase everything from the file, and then you start fresh. Okay. So if you're going to write a longer line, a longer text, it's not going to be a problem because it's always going to overwrite everything, and that's erased. If you write something that's shorter than it was before, then you have part of the old text already. So one solution is that you can erase everything else. Okay. That's one thing you may want to do. The other thing you could try is you don't want to destroy everything. You want to keep everything as they were before, and then right at the end you add something else. Okay. So one is deleting everything, and the second thing I'm talking about is called actually appending, adding something at the end. That's called append. So let us look at both of these things, because right now this is not working. Maybe this is not what we want, right? So if you want to delete everything, this is much easier done. set length 0. You set the length of the entire file to be 0, and let us try this out. Let's just say hi, because if it were like before, then we would have HILLO, right? But just by adding that line, we fixed that problem. Now it says hi. Okay, so that's one thing. What if I wanted to add something right at the end? And in order to do so, we need to know how much of the file has been already written. So right now, you look at this, it says hi, and you see that that's 2 characters long. So if I want to start adding anything new, I'd start from here, after this, okay? So to do that, first of all, I need to know what's the length of the current file. And that we can know through output.get what is that? Output.length. So that tells us how big the file is. It's actually long, so let me leave it as long. Can't type. Alright, so we know the length of the file. Let us just print it out, just so you can see this. So it says the length is 2. If I go for another text, it still says 2 because the previous file had 2 characters in it. And if I run this again, now it says length equal to 10. Okay, so I can know the length of the previous file, and now is the matter of making sure that you write from a place after that. So you say output.seek length. What this seek method does, it takes your file pointer where you start reading or writing from. It takes your file pointer and it goes to that point. See, I didn't mention this yet. The class that we're using is called random access file. In your computer fundamentals course, I think you covered topics about RAM, right? Random access memory. Do we know why this is called random access? What's that? By the word random access, we mean that we can jump to any place in the memory that we want to. We can go anywhere. So a very good example of that can be CD players. Okay. We can have audio CDs and we can listen to the tracks. You can have a remote control and you can say which track you want to listen to. You can jump to that. Okay. And, how many of you have seen cassette players before? The tapes. You had tapes, now you have to put them in. So if you had a chance to play them, you know that you couldn't jump around like that. You have to go sequentially. If you want to listen to song number 5, you have to go through song number 1, 2, 3, and 4. Not that you have to play them, you can fast forward. You still have to go through them. There is no direct jump. Okay? So the reason I'm talking about that is it's the same scenario. In random access file, we have the option to randomly jump to any location. We can go there, just like we can do in our random access memory, our RAM. So with the seek method, we can do so. And now, let's say we add something new. This is some new text. We write that, and we run this project. And let us look at this. So you see, hi, hello, this is here. It's not deleted. And after that, we have some new text. And if I run this project again, this doesn't get deleted. We have this right after that. And this is probably not something you'd want to do, I mean, it's hard to read. We are usually used to writing lines after lines. That's actually our fault, that, well, not your fault, but my fault, that we don't have a new line here. Because when we say output.write bytes, it doesn't add the new line by default. It's your responsibility to add that new line like this. And if you do so, you'd see that this one is placed right over here, but if you run it again, then the next text is brought over here, and if I run this thing again, I have the next line over here. So now it's writing with new lines right at the end. Is this thing clear? Okay. One important thing, it works without it, but it's always a good practice to close the file. I forgot to do so when we were reading. I forgot to do so when we were writing again. So output.close. Okay, it should be there. What does this do? Well, this is not output. This is input rather. You see, whenever we are reading from a file or writing to a file, we need some resources from the operating system. Right? You need some memory, and you need some CPU power. So when you have a file pointer reading from the external resource, it uses resources from your operating system, and when you don't need them anymore, it's always a very good practice to give them back, because resources are limited. Your RAM is limited, your CPU power is limited. So when you give that back, the OS can give that to some of the program that's running in your system. So stuff like these, whenever you open a connection, you should close that. A file pointer, be it a file pointer, be it a network connection, be it a database connection. If you open that, it's your responsibility to close it. Your program will work, but it will hold on to the resource till it's done. So that's why as soon as you're done, just let go of it. Okay. So, easy stuff. Input.close or output.close, or whatever your object is named. Close. Okay. Now, if you understood these two things, I want you guys to try something based on this knowledge only. Right? It's a very simple task. You have to write a program, you'll give the file name, the input file name and the output file. The task is to copy the entire content of the input file to the output file. Okay. And we have similar programs. Let me show you. In Linux, if I go to this directory, where is it? It's in NetBeans projects, it's in Spring 2018 Java. We're talking about file.io. If I go here, I see we have input.txt. Yeah, right here. So you see that here we got input.txt. It's a 90 bytes file, and I can copy this with a command called cp. I can say input.txt to say input1.txt, and now you will see that there are two files, and the content of them are the same. So this is a program, this cp is a program that takes two parameters, input.txt and input1.txt, copies the content of input.txt to input1.txt. And that's what I'm asking you to do, to write a program like this that copies things from one file to another. Okay. All right. So we are pretty much at the end of the class. Time ran out. In our next class, I will design a user interface, and I'll add some file.io to that. I'll show you some other contents, like controls rather, like list view that you'd find useful for your banking tool. We'll go from there. Any question about any of these things? No? Okay, so today's 3rd March. When's our exam? Okay. Tell you what, we got another class on 8. That would probably be too late. Oh no, the exam is on the 14th, so we got time. Please remind me on the class of 8 to talk about the question pattern. I'll tell you textbook chapters and topics that we covered and what would be the questions like. And also give me a reminder if I don't post the previous semester's question on our classroom. I want to do that, but if I forget, please give me a reminder. And we got a lab exam in our lab class, a quiz.